Welcome to Cosmic Compass, the channel where we journey beyond the ordinary night sky to uncover the deeper stories of our universe. Together, we'll explore the planets, stars, and cosmic phenomena, not just as distant objects, but as worlds full of mystery, beauty, and science waiting to be discovered. Today, let's take a closer look at Jupiter, not in the way our eyes usually see it, but across the hidden colours of the electromagnetic spectrum. From glowing heat maps to dazzling auroras, Jupiter will reveal itself as you've never imagined before. What if our eyes could see far beyond the narrow band of visible light? Imagine looking at Jupiter not just as a golden sphere wrapped in clouds, but as a world glowing with heat, shimmering in ultraviolet, and revealing secrets hidden deep within its atmosphere. We're used to seeing planets in natural light, Saturn's golden hues, Jupiter's striped bands, Neptune's deep blues. Beautiful, yes, but also limited. Beyond visible light lies a spectrum full of information waiting to be uncovered. And that's what we're about to explore Jupiter and its moons, not as you've seen them before, but through the wider lens of the electromagnetic spectrum. Let's begin with what we know best. In visible light, Jupiter is stunning, swirls of browns, reds and whites dancing across its vast atmosphere. But unlike Earth, these clouds are not made of water. They are ammonia ice clouds rising and falling across different altitudes. Look closely and the contrasts become clear. Darker regions are not shadows of clouds we would recognize, but rather gaps between towering bright formations. Higher altitude clouds appear whiter, even snowy, while lower ones take on deeper colors. Scientists believe these colors are shaped by chemistry and sunlight. Compounds from deep within Jupiter rise upward, only to be bombarded by ultraviolet radiation from the sun. This changes their chemistry, darkening them before they sink again. A constant cycle, a living canvas painted by physics. But notice something: no matter how detailed these images of visible light shows us only the very top of Jupiter's atmosphere. Everything beneath remains a mystery, and that's where other wavelengths come in. Now let's shift to infrared. At the 4.68 micron wavelength, Jupiter transforms. Instead of seeing colours, we see heat. Images from the Gemini Observatory reveal that Jupiter shines brightest in its lower reddish bands. Why? Because Jupiter generates more heat than it receives from the Sun. The planet is still slowly contracting under its own gravity, and that compression produces energy. This heat escapes most easily where clouds are thin. Suddenly, features we know so well, the Great Red Spot, the pale white bands, appear dark. With the Juno spacecraft orbiting Jupiter, the picture becomes even richer. Infrared observations allowed scientists to build a 3D map of the poles, revealing vast cyclones. At the North Pole, 9 vortices swirl endlessly, 8, circling one giant storm at the centre. Even the temperatures surprise us. The warm areas glow at only 13 degrees, while higher, darker clouds sink to 83 degrees. Not warm at all by our standards, but astonishing compared to the freezing depths of space. And because this heat comes from Jupiter itself, infrared lets us watch day or night, sunlight or no sunlight. Storms can even be detected in infrared before they appear in visible light. Imagine being able to forecast Jupiter's weather in advance. It's science fiction but real. Now let's turn to Io, Jupiter's volcanic moon. In visible light, Io looks mottled and strange, but in infrared, the picture is breathtaking. Even on its night side, the surface blazes with hotspots, volcanoes erupting continuously, releasing fountains of lava into space. Juno's glimpses confirm what we suspected. Io is the most volcanically active body in the solar system. From orbit, it looks like a glowing coal alive with fire. A hellish yet captivating world. Europa, by contrast, tells a quieter story. Through the 1.5 micron water band, we see not just ice, but the quality of that ice. Deep blues indicate pure water ice, while other colours reveal mixtures with minerals. This is spectroscopy, the science of decoding light. When white light reflects off molecules, some wavelengths are absorbed. By examining what's missing, we can identify the molecules present. Applied to Europa spectroscopy reveals patches rich in sulfuric acid, often near cracks in the icy surface. Some of it likely seeps upward from the ocean beneath. Some arrives from Io's volcanic eruptions carried across space by charged particles. In other words, Jupiter's moons are not isolated. They exchange matter, energy, and chemistry, all within the planet's vast magnetic field. Callisto, the outermost of Jupiter's large moons, offers another kind of puzzle. Infrared images, overlaid on visible ones, show craters rich in water ice. At one site, the central crater gleams with ice, as do the rays spreading outward. But curiously, there is a ring around the crater where ice seems absent, a gap, almost like a forbidden zone. Why, perhaps, the debris from the impact fell only beyond this distance? Or maybe the surface here hides another unknown process. What it tells us is simple non-ice material on Callisto is thin, only a coating. Beneath it lies a world of ice preserved for billions of years. Infrared doesn't just show us heat or water. Different wavelengths reveal different secrets. At 1.61 and 2.73 microns, Jupiter looks familiar, showing cloud decks much like visible light. But at 2.17 microns, the absorption band of hydrogen, Jupiter's true identity, emerges. Being mostly hydrogen, the planet turns opaque at this wavelength. Only the tallest, highest clouds rise above the haze, glowing faintly. At 301 microns, methane and ammonia absorb light, creating new contrasts. At 499 microns, we return to a heat map glowing from within. Combine these bands, and scientists create the false colour images. You've seen vivid, striking pictures that are not art but coded science. Each colour tells a story about chemistry and structure. What about ultraviolet light? Unlike infrared, ultraviolet is less useful for studying atmospheres. One rare exception was in 1994 when comet Shoemaker-Levy 9 slammed into Jupiter. The dust absorbed ultraviolet light, allowing scientists to track high-altitude winds as the scars drifted. But Jupiter shines in ultraviolet in another way, its auroras. Unlike Earth's fleeting northern lights, Jupiter's auroras are permanent, roaring beacons at the poles. Charged particles stream along magnetic field lines, smashing into the upper atmosphere. Io plays a key role, pumping material into Jupiter's magnetosphere, fueling the auroras. Hubble has tracked these glowing curtains in ultraviolet for years. Meanwhile, Juno provides close-up views in infrared, flying directly over the poles. The result is spectacular auroras, more powerful than any seen on Earth, a reminder of Jupiter's dominance in the solar system. Step back, and the message is clear. Visible light shows beauty, but only the surface. Infrared and ultraviolet reveal what lies beneath, what burns within, and what blazes above. Through spectroscopy, we identify molecules without ever touching them. Through heat maps, we peer into weather systems. Through auroras, we glimpse the power of magnetism. Each wavelength is a different language, and together they tell Jupiter's story. The lesson: never settle for what the eye alone can see. The universe is richer when viewed through all its colours. We've just explored Jupiter in a way that natural light could never show us. But what about Saturn, Uranus or Neptune? What secrets might they reveal when we look at them with new eyes? If you'd like to continue this journey, let us know in the comments below. And if you enjoyed this exploration, consider supporting Cosmic Compass with a like and subscription. Together, we'll keep uncovering the hidden stories of the cosmos, one wavelength at a time. This is just one glimpse into the hidden layers of our universe. Every planet, every moon, every corner of the cosmos has a story to tell if we know how to look. At Cosmic Compass, We'll continue navigating these stories together, uncovering the science that makes the universe both understandable and endlessly awe-inspiring. So, if this journey sparked your curiosity, join us by subscribing, liking the video, and sharing it with others who wonder about the cosmos. And remember, the universe is vast, but with the right perspective, it becomes a little closer to home. Until next time, keep exploring and keep looking up.